All right, section 9.4 is the tangent ratio. We're going to look at three of the ratios. We're looking at the tangent today. We'll look at the other two tomorrow. So the tangent ratio is a trigonometric ratio for acute angles that involve the lengths of the legs of the right triangle. So let triangle ABC be a right angle with an acute angle A. So we're talking about this angle right here. And the tangent of angle A, written as tan A, is defined as follows. The tangent of A is the length of the leg opposite angle A. So remember, you can always draw a line or an arrow from the angle to the opposite side. So that's so BC, as you can see, is the length of the opposite side, and then the adjacent means next to. So the length of the length of the leg adjacent to A, or BC over AC. Okay, so example 1, find tangent of A and tan B. So write each answer as a fraction and as a decimal to 4 places. So let's go ahead and start with A. So if we look there, we're going to say that the tangent of angle A, again, I can always draw an arrow to the opposite side. So we're going to say that is 15 over adjacent means next to. And remember, you're going to tell me, well, I have two adjacent. Well, one of them is the hypotenuse, because remember, the hypotenuse is always opposite the right angle, which we can see right there. Okay, so the adjacent one in this case would be 36. And when they're asking you to do it as a fraction, please make sure that you reduce the fraction. All right, so we can see that 3 goes into 15 and to 36. So we can reduce that to 5/12. And then it says to 4 decimal places, so 0.4167. They also want us to do tangent of B. So here's my B, okay? Again, I can always draw an arrow to the opposite side. So on that one, we can say that the tangent of B is equal to 36. On this one here, 15 is the one adjacent to it. And again, reduce it to 12/5. And then put it in your calculator. That would be 2.4000. Okay. Example 2, find the value of X, round your answer to the nearest tenth. So again, it might have a degree already set for us, and we'll have to solve for something else. So we're going to look there. That's our angle that we need, because we have this side and we have the adjacent. Those are the only two things that are marked. So what can we say here? We can say that the tangent of this case, it's 25 degrees. We already know what it is, all right? And then that is going to equal 12 over X. So again, if you want to think about it, I can put this over 1, and then I can take my cross products. So we can say that X times the tangent of 25 is equal to 12 times 1, or just 12. Okay, and then if we take that, we'll take X is equal to 12 divided by the tangent of 25. So again, you're going to use your calculator. Please make sure your calculator is in the degree mode, because if it is, your answer would be approximately 25.7 degrees, because they said to the nearest tenth. All right, on this one here, it says use a special right triangle to find the tangent of a 30-degree triangle. So what they're telling us on that one here, again, remember, my drawing doesn't have to be perfect, but they're telling us it's 30. So remember, when it was 30, it was a 2a, a square root of 3. So let's say our a is 1, then we'll have 2 times 1, and we'll have 1 times the square root of 3. So we're talking about this angle here. So again, we can go to the opposite side, all right? And then we can say that the tangent of 30 degrees is equal to, and remember that is a right angle, is equal to 1 over the square root of 3. Okay, now remember, we have to rationalize the denominator here. So we're going to have to say it's times, let me use a different color, times the square root of 3 over the square root of 3. So when we do that, we'll get the square root of 3 over 3. And if you plug that into your calculator, you should get 0.5773. And they're just asking you to show that that is right. So if you plugged in tangent of 30 in your calculator, that is the answer you should get. They're just showing you can find it using special right triangles too. All right, and then our last part, the angle that an upward line of sight makes with a horizontal line is called the angle of elevation. So example 4, you are measuring the height of a tree. You stand 40 feet from the base, and the angle of elevation to the top of the tree is 65 degrees. Find the height of the tree to the nearest foot. So let's see here. Why don't we make a nice little tree here? So I'll even put a brown base on it because I can. All right. Now remember, I'm not the best drawer. You're probably not either. But remember, so it's saying we are standing 40 feet away from it. So here's our 40 feet. Here's our line of sight. We're probably on a mountain, so that's okay. All right. And then it says that the angle of elevation. So we're going to take, and from our line of sight, we're going to say that, and there is our 65 degrees. Okay. Now we're going to assume some stuff. We're going to assume that that is a right angle, and we're going to say then that we need to find the height. All right. So like before, I can always draw an arrow to my opposite side. So in this case, we're going to say that the tangent of 65 is equal to, well, our opposite is h, and our hypotenuse, our adjacent side, is 40. Okay. So now, again, to get h by itself, I'm going to multiply both sides by 40. So I'll get that h is equal to 40 times the tangent of 65 degrees. And if we plug that into our calculator, since they want it to the nearest foot, we get 85 point something, but when we round it to the nearest foot, we'll get 86 feet. All right, so check those out on your calculator. Make sure you get the same thing, because if you don't, then your calculator's probably in radians, and you don't want it to be in radians, you want it to be in degrees. All right.